Good evening, ladies and gentlemen. Good day, good evening. I see that we have a guest beyond Africa. Very good evening, ladies and gentlemen from all countries of Africa and beyond. Today, we are very honored to have invited Madame Phoebe Ndeda from Kenya, who's going to give us the second session of the presentation. The first session is going to be taken by me. I'm going to talk about a new paradigm of cancer. After that, Madame Phoebe is going to give us a presentation on cancer prevention and management with Greenwood products. So please first let me share of slide. I hope you can follow me because this is a brand new idea about cancer. Actually, I read books about the latest study of cancer. So although we talk about cancer a lot, but still, this book really, really impressed me. And this is going to help us to understand what really cancer is. Because only by understanding what cancer it is, we know that how to control the cancer from the root. And we know how to complement the current treatment of cancer. Okay, so first of all, let me share this. Just give me one moment. Okay. First of all, I have to say that uh, it's a lost battle against the cancer. It is a very sad facts, actually. In 1986, Dr. John Baylor the third, who served as a consultant to the New England Journal of Medicine and a lecturer at Harvard School of Public Health, questioned the effectiveness of the entire cancer research program in an editorial in the New England Journal of Medicine. In the article, Dr. Dillon noted that from 1962 to 1982, the number of Americans who died of cancer increased by 56%. I'm going to adjust the voice. Okay, so actually it increased by 56%, adjusting for population growth. This still represented a 25% increase in the rate of deaths from cancer at a time when death rate from virtually every other disease were dropping quickly. Crude death rates from causes other than cancer had decreased by 24%. So actually, this was a very sad situation. Now, this help us to understand the first paradigm of cancer. Over the last 100 years of understanding of cancer has undergone three major paradigm shifts. First, we considered cancer a disease of excessive growth. That's certainly true. Cancer is a growth, but this didn't explain why cancer was growing. Cancer was first understood as an exuberant, unregulated, and uncontrolled growth of tissue. Normal tissue have well-defined growth patterns. A normal kidney, for example, grows from birth, until adulthood and then stops. It then simply maintains its size unless other diseases intervene. A normal kidney does not continue growing throughout life until it is so big that it takes up the entire abdominal space. Cancer cells, however, will continue growing until they die or you die. So cancer is not a foreign invader. It is an internal uprising. The war on cancer actually is a war on ourselves. The first great paradigm of cancer, what I call the cancer paradigm number one, deems cancer an unregulated growth of cells. If the problem is too much growth, then the solution is to kill, right? In order to kill, you need weapons or cellular mass destruction for cutting, surgery, burning, radiation, or radiotherapy, and poisoning. Um, that is what we call the chemotherapy. For localized cancer, you could use the locally destructive method. You use the surgery or radiation. For metastatic cancers, means if the cancer already spread to other place of the body, you need systemic poisons. We call it the chemotherapy. But do radiotherapy or chemotherapy, excuse me, please remember to mute yourself when you enter of a Zoom meeting. So the question is, do radiotherapy and chemotherapy slow down the occurrence, even the reoccurrence of cancer? Everyone knows the answer, no. Otherwise, if both of them works very well, we won't witness the great increase of the death rate of cancer. Obviously, there's something wrong with the first paradigm. So the first paradigm said that cancer is growth. This is true. But if it is only a growth, by cutting it or by killing it, it can definitely control the cancer. But unfortunately, we couldn't control cancer with those conventional therapies. So this tells us something wrong with the first paradigm. Now, before we discuss about the second paradigm of cancer, we need to ask ourselves a question. What causes cancer? Chemical carcinogens such as asbestos, tobacco, and soot cause cancer. Physical carcinogens such as radiation also cause cancer. Infections, both viral and bacterial, are also carcinogens. And they're not so rare, with an estimated 18% of cancers having infectious disease origins. The main agents are Helicobacter pylori, the bacteria that can invade of stomach wall, human papilloma viruses, that is the viruses cause the cervix cancer, hepatitis B and C viruses, normally causing the hepatitis, and liver cancer, and Epstein-Barr viruses cause the cancer of your nose, and also HIV, we all understand, and a few others. So all these factors cause accumulated genetic mutations in key genes within a single cell. So these mutations disrupt the normal control system that regulates the cell growth, division, and death. So the two main types of cancer-causing genes, there are two primary classes of genes that, when muted, drive cancer development. A useful analogy is to think of a car's controls. The first group is the oncogenes, or we can think about it, the stack accelerator. Normal functions, proto-oncogenes. So this kind of genes are the gas pedal. They make proteins that promote and signal normal cell growth and division. So when the proto-oncogenes undergoes a gain of function mutation, for example, point mutation or gene amplification, it becomes an oncogene. It becomes permanently switched on, sending continuous grow and divide signals to the cell, even when it shouldn't. So it's just like a stack accelerator in a car, causing uncontrolled speed. I give you a few examples. HER2, commonly amplified in breast cancer, leading to many HER2 proteins that drive rapid growth. Another kind of mutation is BRAF. The BRAF V600E mutation is found in melanomas and other cancers, keeping a key growth pathway constantly active. Also, we have the RAS. This is a family of oncogenes frequently muted in pancreatic, colon, and lung cancers. So you see, this is one kind of genes. Now, we also have the second group of genes, tumor suppressor genes. We call it the failed bricks, like the failed bricks in your car. Normal function, these genes are the bricks. They make proteins that slow down cell division, repair DNA mistakes, or tell damaged cells to die. This is a process called apoptosis. So when a tumor suppressor gene undergoes a loss of function mutation, the bricks fail. The cell can no longer stop itself from dividing, even when it has severe DNA damage. So it is like failed bricks in your car, making it impossible to stop. So the key examples, P53, I think a lot of people have heard about this, known as the guardian of the genome. It is mutated in over 50% of all cancers. It normally stops cell division to allow for DNA repair or trigger cell death if the damage is too severe. So when P53 is broken, damaged cells survive and multiply. Also, we have the RB1. We call it the retinoblastoma. Its mutation causes a rare eye cancer in children. Normally, the RB8 protein acts as a crucial checkpoint for cell division. Also, we have the BRCA1 and BRCA2. From the name, you got it. They cause the breast cancer. Not only breast cancer, but also ovarian cancer. So these are critical for repairing damaged DNA. Mutations in these genes significantly increase the risk of breast, ovarian, and other cancers because DNA errors accumulate rapidly. So if those genes undergo mutation, it means that, the bricks in your car get a failure. Your cars can never stop. This is a disastrous situation. Now, where do these mutations come from? This is another question. Cancer-causing mutations can be inherited. That means, we were born with a mutation in every cell of your body, passed down from a parent. This doesn't mean you will definitely get a cancer, but it means you start life with a higher risk. So this is the first hit. Now, we also have acquired or somatic. These are the most common type. They occur during your lifetime due to random mistakes when cells copy their DNA before dividing, or exposure to carcinogens like tobacco smoke, UV radiation, certain viruses like HPV and asbestos. So the two-hit hypothesis, excuse me? Phoebe, Madam Phoebe, I'm going to mute yourself for a moment. Once you start your presentation, I'm going to unmute you. So the two-hit hypothesis, for many tumor suppressor genes like the RBA, both copies of the genes from each parent must be damaged to cause a cancer. So a person might inherit one faulty copy, which is first hit, and then acquire a mutation in the second. Healthy copy in a single cell later in life. So this is the second hit. So it means an individual experience the first hit and then the second hit. Then that individual will develop cancer. Now, let's take a look at the second paradigm of cancer. So understanding the specific gene mutations driving a cancer has a revolutionized treatment. So this is the basis of precision medicine. Example, if a patient breast cancer is found to be HER2 positive, they can be treated with a drug like the Herceptin, which specially targets and blocks the HER2 protein. Or if patients with melanoma harboring the BRAF V600E mutation can be treated with drugs like the vemurafenib, which specifically inhibits the malfunctioning BRAF protein. So most cancer contain numerous changes to both oncogenes and or tumor suppressor genes. So these new discoveries seem to offer a perfect explanation for why cancer cells grow so quickly, both activating mutations of oncogenes and inactivating the mutations of tumor suppressor genes could accelerate the cell growth, leading to cancer. So this coalesced into the widely accepted somatic mutation theory, which views cancer primarily as a disease caused by accumulated genetic mutations. Somatic cells include all cells of the body except for germ-line cells, the cells responsible for sexual reproduction, such as the sperm and the egg. Mutations in these somatic cells, such as the breast, the lungs, the prostate, the ovaries, the eyes, pancreas, accumulate, and a random aggression of this mutation may be enough to cause cancer. So this wheel of cancer, what I call it the cancer paradigm number 2, dominated cancer research in the 1970s and is still championed today by the American Cancer Society, which states plainly that cancer is caused by changes in the cell's DNA, its genetic blueprint. Now let's take a look at this. Is the second paradigm comprehensive? Is it completely true? By the 2000s, hundreds of potential cancer-causing genes had been identified. Everywhere researchers looked, there are more oncogenes and tumor suppressor genes. Presumably, a single mutation in any one of the normal growth controlling genes could cause cancer. So why wasn't everybody getting cancer? One more question. How many cells had genetic mutations but were not cancer? So this number turned out to be pretty high. A full 4% of a cell's DNA could have mutations, and that cell could still look and act normally. So this is a remarkably high degree of tolerance. So if we estimate that there are 25,000 genes in a human, then you could have roughly 1,000 genes mutations without developing cancer. Here's another fact. Genetic sequencing of esophageal specimen taken from organ donors with no prior history of cancer has also yielded more stunning results. The average healthy cell with no evidence of illnesses or cancer contained at least several hundred mutations per cell in people in their 20s, rising to over 2,000 mutations per cell late in life. So the Notch1 oncogene, for example, considered to be the prime driver mutation of esophageal cancer. So it is present in about 10% of all such cancers. Also found to be present in up to 80% of all esophageal cells in patients free of cancer. So it means that even if you don't have cancer, you have a lot of mutated genes. So how come this? 80%. So in middle-aged and older specimen, 2,050 mutations were found in that single oncogenes, not developed into cancer. In other words, the seed was there, but cancer had not grown. So cancer patients had lots of mutations, yes, but so did cancer-free people. Some healthy people even had the identical genetic mutations as those with cancer. A 2012 detailed analysis of 31,717 cancer cases concluded that the vast majority of, if not all, aberrations that were observed in the cancer-affected cohort were also seen in the cancer-free subjects. So that is to say, either you have cancer or you don't have cancer. You also share the common mutated genes, and there are quite a lot of them. So recent genetic sequencing of discarded skin from cosmetic surgeries completely free of cancer has yielded also astounding result. Almost 1 in 4 samples contained mutations known to be involved in cancer, and yet no cancer was present. So this discoveries makes us ask the important questions not asked was, how many normal cells carry the very same mutations in the cancerous pathway but do not develop into cancer? Can gene mutation explain all this? Because, the second paradigm of cancer believed that cancer was caused by gene mutation. But the point is, the cancerous patients, they have gene mutation, which we all understand. But the point is, the people who don't have cancer also have almost the same amount of gene mutations. How come? Then does the gene mutation can explain all this? So let's go ahead to learn more. Selective pressure. Cancer's deep evolution, cancer's deep evolutionary roots run way past the origins of mankind. So this is very interesting. Right back to the origin of multicellular life on Earth. So what is cancer? The simple answer is this. Cancer is a unicellular organism, but in order to transform itself from a normal cell in a society with rules for corporations to a unicellular existence, it had to undergo hundreds or thousands of genetic mutations. The next question to answer is, what guided the selection of these mutations? Cancer cells evolve toward a clearly defined destination, unicellularity, with the resolute purpose and tenacity of a bloodhound. Cancer cannot exist outside the host and is not transmissible. So a highly successful cancer kills its own host and ultimately kills itself in the process. The more lethal the cancer, the more suicidal it is. But why does cancer evolve towards a form that will ultimately kill itself? The principle of evolutionary biology offer insight. First, cancer behaves like a unicellular animal. Bacteria grow in a petri dish will continue to grow until the food runs out. They make no efforts to reduce growth in response to the obviously depleting food resources because each individual cell is concerned about only its own growth at that time. Grow until the food is gone. Then they die. So this is precisely the same growth pattern seen in cancer, which continues to grow until the host organism dies. At that point, the cancer must also die. Second, cancer largely strikes older adults longer after the reproductive phase of life. Genes that increase the cancer risk are still passed on to the next generation. For example, the BRCA1 genes significantly increase the risk of both breast and ovarian cancer. The average age of diagnosis of breast cancer is 42.8 years, let's say almost 43 years, often after women has had children. Thus, despite the lethality of the cancer, the BRCA1 gene has already passed on to the next generation. So the persist in the population. So this is why we can inherit the mutate genes. So cancer differs from other genetic disease because it evolves. Sickle cell anemia, for example, is also caused by genetic mutation that is identical in all cases and stable over time and space. But cancer cells have mutations that change constantly from person to person and even within the same person over time. But if cancer are constantly and independently mutating, then how did they end up so similar, sharing all the same hallmarks? So the Adventist theory proposed that cancer is the unicellular ancestor of a normal cell. Okay, let me put this way. When life exists in the earth, at the very beginning, it is a unicellular. We call it the ancestor of cells. Later on, the cells get together and then, they form, let's see, plants, animals, then humans. So now we humans, actually we in our body we contains trillions and trillions, actually around 60 trillions of cells, and all these cells, they form different teams. Then we call it organs and systems. So some cells are responsible for digestion, some cells are responsible for breathing, some cells are responsible for of heart beating. So actually they collaborate. And secondly, we talk about that once they grow into a certain size. So let's see, when an adult individual reach 18 years, all of our organ, actually reach the peak size. Then after that, all these organs stopping. It's impossible that, when we getting aged, then, of organs are still growing bigger and bigger and bigger. Now, this is impossible. We have controlled cell growth. But the single cell, the unicellular ancestor of cell, they don't do this. They only grow uncontrollably. As long as there's a food, they can non-stop grow. So actually cancer wants to go back to become of ancestor cells. So this is the ultimate goal of the cancer cells. So they want to, they want to grow. They want to be immortal, move around and use the glycolysis. The glycolysis means even when we can provide the glucose, the oxygen, they still use their unique way that they don't use oxygen. And then they use a lot of glucose to quickly produce energy for their quick growth. So, as multicellularity evolved, new genetic instructions were added to stop growth, make cells normal, stop cells from moving around, and change energy generation to favor the OXPHOS, the oxidative phosphorylation. So actually, cancer cell doesn't listen to this at all. They have only one goal. They want to become immortal. They want to become, an ancestor cells that they can continuously grow. So this is why cancer keep on, achieving this goal throughout their life until cancer kills us. So this helps us to understand the third paradigm of cancer. That cancer paradigm second suggested that cancer is a disease of genetic mutations that cause excessive growth. This is true. It's certainly true, but again, it does not explain why these mutations occur. So this leads to cancer paradigm 3, the evolutionary theory, which postulates that gene mutates as a survival response against chronic sublethal injury. The drive towards a unicellular state, the most basic unit of survival, is the force behind mutations. So Charles Darwin's theory, as applied to cancer, is best summed up by the paraphrases, it is not the strongest species that survive, nor the most intelligent, but the ones most responsive to change. So cancer is the ultimate cellular changeling fighting for its own survival. So this powerful enemy has been shaped by the most potent known biological force, evolution. So cancer cells is the result of evolution. Now, I give you another very interesting facts about cancer. Obesity, the relation between obesity and cancer. So the cancer prevention study, second, a large prospective cohort study began in 1982. This massive scientific undertaking required 77,000 volunteers simply to enroll all the participants, which numbered over 1 million. The participants average age 57, were healthy and free of any detectable cancer at the beginning of the study. So every 2 years, they were tracked to see who had died and why. In 2003, the data reached a then normal and stomach-churning conclusion: obesity. Already a well-known risk factors for diabetes, for heart disease, and stroke, also significantly raised the risk of cancer. So the risk of cancer began to rise at an BMI greater than 30. If somebody has a BMI greater than 30, it means obese, and accelerated in those with a BMI over 40, who suffered 52 to 62% more overall cancer deaths. The risk differed by cancer site. The risk of liver cancer is increased by 4,052%, and the highly lethal pancreatic cancer risk is increased by 261%. So this is devastating news, but the truth is almost certainly worse for two reasons. People found to have lung cancer from smoking tend not to be obese because of smoking is, make people slim. Because lung cancer is the most significant cause of cancer deaths. So this means that the 42 to 62% increased risk of cancer with obesity is almost certainly an underestimate. So looking at non-smokers only, the increased risk of cancer for BMI over 40 is a disastrous 88%. Second, advanced cancer patients tend to lose weight, a phenomenon known as cancer cachexia. So this will similarly obscure the true link between obesity and cancer, and once again leads to underestimation of obesity's true risk. So let me put it in a very common way to express this. Obesity definitely increased risk of cancer, and it is much worse than what we thought. Okay, so let's take a look at over the ensuing years, the news on obesity and cancer has only gotten worse. In 2017, the CDC released a report highlighting the trends in incidence of cancer associated with overweight and obesity. United States 2005 to 2014, some of the most common cancers, including breast and colorectal, are related to obesity and excessive body fatness. Together, this accounted for an astounding 40% of all cancers. So the specific cancers most tightly linked to obesity are liver, endometrial, esophageal, and kidney cancers, with 2 to 4 times the risk. Breast and colorectal cancer are more moderately associated, at 1.5 to 2 times the risk. In 2016, the International Agency for Research on Cancer, after reviewing more than 1,000 studies, concluded that 13 different cancers are clearly obesity-related. 3 other cancers had limited data but were suggestive. So even mild weight gain is associated with increased cancer risk. Adult weight gain of only 5 kilograms, that is almost 11 pounds, increases risk of breast cancer by 11%, ovarian cancer by 13%, and colon cancer by 9%. So being overweight or obese, which means the BMI is over 25, almost double the risk of cancers of the esophagus, liver, and kidney, and increase colorectal cancer risk by about 30%. So this is a very astounding fact between the obesity or even overweight and cancer. Now, let's take a look at, does weight loss lower the risk of cancer? Because, if we see that obesity and overweight is definitely linked with cancer, now we want to know, does weight loss lower the risk of cancer? So if weight gain increase the cancer risk, does weight loss lower it? The first animal studies that suggested this possibility were published over a century ago. By 1940, Nobel laureate Peyton Royce in mice severely restricting food availability cut their risk of cancer by half. In the 1940s, Dr. Albert Tentable, former president of the American Association for Cancer Research, discovered that, astonishingly, carbohydrate restriction alone in mice provided greater protection against cancer than overall calories restriction. He concluded that tumor formation is dependent on composition of the diet, as well as the degree of caloric restriction, a remarkable prescient observation. In the Nurses' Health Study, women who lost 10 kilograms or more after menopause had kept the weight off, lowered their risk of breast cancer by an astonishing 57%. So now, I'm a postmenopausal woman, so I know how easy to gain weight after menopause. So actually, believe me, even if I eat a little bit more in one meal, in one dinner, for example, today I was invited to a party or a buffet dinner. So, I happenly to be very happy and, not very self-disciplined. So I eat more. Believe me, the following day, tomorrow, I will find that, I gain half kilo of body weight. And the point is, to lose that half kilo of weight is extremely difficult. Now I swim 1,000 meters every day. Let's say not every day, 5 days in the week. Still, I find losing even half kilogram is extremely difficult. So, after menopause, for women to gain body weight is super, super easy. So believe me, if you can lose, let's see, cut the body weight for 10 kilograms, but believe me, 10 kilograms is very difficult, then it's going to decrease your risk of breast cancer by almost 57%. So, for the sake of your health, especially women after 50, you got to really, really pay attention to your body weight control to lower the risk of cancer, ovarian cancer, and even colorectal cancer. Okay, now let's talk about cancer cells and insulin. Obesity is primarily a disease of hyperinsulinemia, of course, high insulin level. So the word hyperinsulinemia is derived from the prefix hyper, means excess. It's, the suffix emia means in the blood. So it means that hyperinsulinemia is translated literally as too much insulin in the body. So obesity is commonly mistaken for a disease of excessive calorie intake, but it is in fact mainly a hormonal disorder of excessive insulin. So type 2 diabetes is similarly a disease of hyperinsulinemia, although in this context it is often termed insulin resistance. So like Superman and Clark Kent, hyperinsulinemia and insulin resistance are one and the same. So the cancer-provoking potential of insulin was noted as early as 1964. In lab cultures, normal breast cancers incubated with insulin proliferated with such enthusiasm that they resemble cancers. Growing breast cancer cells in the laboratory also requires insulin. Lots of insulin. This is an interesting observation because normal breast cells don't really need insulin. Yet, breast cancer cells can't live without it. So if you remove the insulin from the breast cancer cell culture, the cells quickly shrivel up and die. So this holds true for other cancers like colorectal, pancreatic, lung, and kidney too. So in mice, injecting insulin induced the growth of breast and colon cancer. So this was a puzzling anomaly. The main tissues normally involved with glucose metabolism, the liver, fat cells, and skeletal muscles, naturally have the highest numbers of insulin receptors. So normal breast tissues, not so much. So why does breast cancer thrive on insulin? Breast cancer cells express 6 times the levels of insulin receptors compared to normal breast cells. High insulin levels can be measured with a blood test called the C-peptide, which is a protein fragment left over from the body's manufacturing of insulin. So high C-peptide levels are associated with an astounding 270% to 292% increased risk of subsequent colorectal cancer. So the women in the nurse health study with the highest level of C-peptide had a 76% higher risk of colon cancer. So injecting exogenous insulin, a drug more and more commonly prescribed for type 2 diabetes, also increased cancer risk. In the United Kingdom, the number of people with type 2 diabetes who are treated with insulin had weight gain actually they grow dramatically from an estimation 37,000 in 1991 to 277,000 in 2010. Weight gain is a major side effect, causing an estimated 2 kilograms of weight gain for every 1% reduction in the hemoglobin A1C, a blood test that reflects the average blood glucose over 3 months. This sounds ominous, as weight gain is a known risk factor for cancer. As researchers dug deeper, the news was not good. In the United Kingdom's General Practice Research Database 2000 to 2010, insulin treatment increases the risk of cancer by 44% compared to metformin, a treatment for type 2 diabetes that did not raise insulin levels. 44%. This was staggering. But this study was not the only one that found insulin treatments to be dangerous. Data from province of Saskatchewan, Canada, confirmed that newly diagnosed diabetic starting treatment with insulin had a 90% higher risk of cancer compared to those taking the drug metformin. So the sulfonylurea drugs, which stimulate insulin secretion, were also linked to a 36% increased risk of cancer. So more insulin equals more cancer. It's a pretty simple concept. The longer one injects insulin, the higher the risk of cancer. Now, let's take a look at the 8 hallmarks of cancer cells. Cancer cells share common. The hallmarks of cancer is a seminal concept in oncology. So first proposed by Douglas Hanahan and Robert Wittberg in 2000 and updated in 2011. It described the core functional capabilities that virtually all cancer cells acquire as they develop into the malignant tumors. So here the 8, originally 6, but later on expanded to 8 hallmarks of cancer cells. So the original 6 hallmarks, or the core capabilities, including sustaining proliferative signaling. So cancer cells generate their own growth signals and are not reliant on the external cues from the body. They're self-sufficient. They're just like the stuck accelerate pedal, often through the mutations in oncogenes. 2. Invading growth suppressors. So cancer cells ignore signals that would normally stop cell division. So they're deaf to the body's stop commands. So they have the broken bricks, often through mutations in tumor suppressor genes. Number 3, resisting cell death. So cancer cells bypass the process of programmed cell death, which is a natural way for the body to eliminate damaged cells. So they are immortalized. They refuse to die when they should, often by inactivating the proteins that trigger apoptosis, or overproducing anti-apoptotic proteins. Number 4, enabling replicatable immortality. So normal cells have a limited number of divisions, but cancer cells can divide indefinitely. So they have the permanently reset life clock, most often by reactivating an enzyme called the telomerase, which maintains the protective ends of the chromosomes, the telomeres. Number five, inducing angiogenesis. Cancer cells can stimulate the growth of new blood vessels to supply the tumor with oxygen and nutrients. So they build their own blood supply network by secreting the angiogenic factors like the vascular endothelial growth factor. Number six, activating invasion and metastasis. Cancer cells gain the ability to break away from the original tumor, invade into the surrounding tissues, travel through the bloodstream or lymphatic system, and form new tumors in other parts of the body. Uh, well, they gain the ability to travel and colonize other organs. This involves changes in cell adhesion molecules and the ability to degrade the extracellular matrix. Then we added two more emerging hallmarks. So these are considered the enabling characteristics that facilitate the acquisition of the core hallmarks, deregulating cellular energetics. So cancer cells alter their metabolism to support rapid growth. Even in the presence of oxygen, they often prefer to use the glycolysis. So this is an effective way to produce energy, a phenomenon known as the Warburg effect. So they rewire their fuel processing factories. So glycolysis provides rapid energy and the building blocks like amino acid and the nucleotides needed to create new cells. Eight, avoiding the immune destructions. The immune cells can normally recognize and eliminating the precancerous and cancerous cells. Successful cancer cells develop strategies to hide from or suppress the immune system. So they develop a cloak of invisibility from the body's police force. So this hallmark is the foundation of modern immunotherapy. So let me actually we come to an end of all the information and knowledges about the cancer. So after we understand all this, you understand how to use of products to prevent and control the cancer. So a new dawn. Uh, let's recap the features of cancer. Cancer paradigm 3. Darwinian evolution is the only known force in the biological universe that can create and coordinate the sheer number of the mutations needed for cancer. The quest for cellular survival drives the accumulation of tens or hundreds of mutations seen in each cancer. So cancer is not only a seed problem, but also in soil problem. So ecology is the study of the relationship between one organism and another, as well as this organism's relationship to their environment. So the evolutionary series does not negate the importance of the genetic paradigm, but it expanded to include both the seed and the soil. So cancer is not just a genetic disease. The evolutionary ecogenic paradigm recognized the importance of cell-to-cell interactions and interactions with the environment, making it evolutionary biology links carcinogenesis, progression, and the metastasis, whereas genetic considers them all as separate issues. So this idea is not new. It just needed to be rediscovered. Cancer is no more a disease of cells than a traffic jam is a disease of car, wrote cancer research D.W. Smithers in 1962. A traffic jam results from the interaction between the car, neighboring cars, and the environment. So if you look only at each individual car, the bricks working? Was it recently serviced? You will fail to find the problem. Similarly, cancer is not only a genetic disease, but also an ecological disease. The environment plays a huge role in determining whether a cancer grows. Under certain conditions, such as high insulin levels, cancer will thrive, while under other conditions, it will fail to establish itself. So the new understanding of cancer has major implications for cancer prevention and treatment. An entire new front on the wall on cancer has now been opened. So we've been able to identify opportunistic targets to break the stalemate of the past 50 years. A firestorm of researchers has enabled the development of entirely new weapons to defeat cancer. Life expectancies are rising. Cancer death rates are falling. So for the first time in living memory, cancer may be on the retreat. So rather than focusing solely on targeting pathological outcomes with high-cost treatments, a more sustainable approach is to cultivate a robust internal and external environment by optimizing the fundamental elements of health, such as nutrition, metabolic function, and inflammatory response, can create conditions that are less conducive to the development and progression of disease. So let me put it in a very simple way. Cancer is not only a disease that you can use the chemotherapy, radiotherapy, or surgery to treat. So this is not only the problem of the seed, also this is a problem of the soil. So if we cannot do anything about the seed, we can definitely do a lot of things about soil. So now, after my section, Madam Phoebe Ndeda is going to present you how to change the soil, how to make your soil not good to grow for the cancer seeds to grow by using the Greenworks products. So I think I'm going to stop sharing my screen and I'm going to hand it over to Madam Phoebe Ndeda. So Madam Phoebe, let me stop sharing the screen. Are you ready to share your screen? Good evening, Madam Phoebe. Madam Phoebe, please unmute yourself. Great. Thank you. Are you going to share your screen?
Yes.
Thank you, please.
Is it okay?
Sure. You can start sharing your screen.
Okay. Thank you very much, Madam Rainy, for that wonderful presentation. I hope we will have those ones, the ones you presented, you send them to our end-user friends so that we can have them again. That was just too much wonderful information. And I'm going to take us through cancer prevention and management. I hope my screen is you seeing my screen, everyone?
Not yet.
Not yet.
Mm.
No.
You click the sharing the screen, and you can start sharing.
Is it now okay? Are you seeing anything?
No, we see your beautiful face.
Wow.
Okay, we'll answer the questions later on. Oh, now it starts showing. Okay, now we can see it. You can maximize it.
Maximum. It's not maximizing.
You can click slideshow. You click slideshow. Here, slideshow. You click slideshow and it's going to maximize. You go to the bar and did you see the slideshow? You click it.
not seeing it.
Okay, it doesn't matter. I can share it with you. Let me do it for you.
Okay.
Just give me 1 second. Just give me 1 second. Let me try to find it. Okay, just give me 1 moment.
Ati?
No, I'm doing it. It starts showing. Just a moment.
Percent where? Is it 40%? This one. Yo. Okay.
You see my screen? Oh no, this is still a new paradigm. Let me go to the other one. Can you see it now? Can you see my screen? Hello.
Yes, yes, yes.
Okay, now you go ahead. I'm going to
Yes.
scroll the slide for you. You just give me a signal. Next page or next slide, and then I'm going to scroll it for you.
Jadi bagi ko solution. Majeng prate ko iwa ko rakiro jok nek mare kardak ma meridian matau bi borne. Manaka ka pinya kidi le antoni. Nanti lo simbong we amo ne
Sorry?
customer.
Sorry. Madam Phoebe, are you going to share your screen or you want me to do it for you?
Okay, just do it because I don't know what has happened here.
No, it's okay. Let me do it for you.
Okay.
Okay. All right. So you may start.
Okay.
Can you see the screen now?
Yes, I can.
Okay. All right. So you go ahead.
Okay. Thank you very much, Madam Rainey.
Pleasure.
So I'm going to take us through cancer prevention and management. And as we have seen, the Cancer Association of South Africa issued the top 10 cancers for Africa, men, and also for women in 2023. So for men, we are having prostate cancer, colorectal cancer, esophageal cancer, non-Hodgkin lymphoma, Kaposi sarcoma. We have squamous cell carcinoma of the skin. We also have stomach cancer. We have penile cancer, laryngeal cancer, Hodgkin lymphoma, and nasopharyngeal cancer. Those are the most types of cancer found in men and in Africa. For women, we have cervical cancer, we have breast cancer, uterine cancer, vulvar cancer, colorectal cancer, esophageal cancer, non-Hodgkin lymphoma. We also have the squamous cell carcinoma of the skin. We have basal cell carcinoma. We have Kaposi sarcoma, and also ovarian cancer. According to World Health Organization, they have revealed some facts about cancer. One of them being that cancer is one of the leading causes of morbidity and mortality worldwide, with approximately 14 million new cases in 2012. The second being that the number of new cases is expected to rise by about 70% over the next 2 decades. Cancer is also the second leading cause of death globally, and was responsible for 8.8 million deaths in 2015. Globally, nearly 1 in 6 deaths is due to cancer. We are also seeing that approximately 70% of deaths from cancer occur in low and middle-income countries. Around 1/3 of deaths from cancer are due to the 5 leading disorders. Yes. Hello. We are also seeing that around 1/3 of deaths from cancer are due to the 5 leading behavioral and dietary risks. Now, these ones are high blood mass index, as we have seen, low fruit and vegetable intake. I'm not audible. Okay, around 1/3 of deaths from cancer are due to 5 leading behavioral and dietary risks. And these ones we see as high blood mass index, low fruit intake, low vegetable intake. Most of us, we don't take enough fruits. Most of us, we fear taking vegetables. Okay. Sorry for that. I'm not edible enough. So around 1/3 of deaths from cancer are due to 5 leading behavioral and dietary risks, which are high body mass index, low fruit and vegetable intake. So most of us, we don't take enough fruits when we are eating, and most of us, we also fear vegetables. And especially African men, we fear vegetables. You find when your wife has prepared you some good meal, and you see in African dishes, we normally have veggies, then we can have some bush meat, we can have some protein source, maybe eggs or maybe fish. So these people who don't like vegetables, they will eat these sweeter things like the eggs or the fish or the meat, and then the vegetables, they will squeeze them out, they put them to the farthest end of the plate, and then they say that, oh, these vegetables have VGTs. These are sticks because they fear eating vegetables. We're also seeing lack of physical activity, tobacco use, and also alcohol use. They're saying also that tobacco use is the most important risk factor for cancer and is responsible for approximately 22% cases of cancer deaths. Cancer-causing infections such as hepatitis and HPV are responsible for up to 25% of cancer cases in low and middle-income countries. What should I do? Okay. I hope I'm now edible enough.
No, it's good. It's very clear. Thank you.
That is very clear. Okay. Okay. So let me repeat that around 1/3 of deaths from cancer are due to 5 leading behavioral and dietary risks. We are seeing high body mass index as being one of them. Low fruit intake, like some of us, we don't get enough fruits. Vegetable intake, most of us, we take low vegetable intake, or some of us, most of us, we fear taking vegetables. Now, any person who fears taking vegetables, just know that cancer is running very close and very fast towards you. So we must be vegetable. We must have vegetables. We must be vegetable, and you must have your vegetables. Let you not be that person when you see vegetables, you squeeze them to the farthest end of your plate, and then you eat the other proteins, and then you leave your vegetables there after they catch up with you. Then we are also seeing a lack of physical activity. Most of us are too lazy to exercise. We also see tobacco use and also alcohol use. They're also saying that tobacco use is the most important factor for cancer and is responsible for approximately 22% of cancer deaths. And cancer-causing infections such as hepatitis and human papillomavirus are responsible for up to 25% of cancer cases in low and middle-income countries. In our previous sections, we've explored the evolving paradigms of cancer, and identified elevated insulin levels as a primary driver of cancer cell growth. Today, we will outline a three-part strategy for cancer prevention and management through targeted lifestyle adjustments. We will focus on the essential roles of dietary choices, physical activity, and also supportive use of renal products. If persistent high insulin is a primary culprit in cancer, we must first understand which foods contribute to insulin resistance. Now, we are going to look at the low GI foods. When we were talking about diabetics, when we talk about diabetes, we recommended low GI foods. So the glycemic index is the value system that ranks carbohydrate-containing foods on a scale from 0 to 100 based on how quickly and significantly they raise your blood sugar levels, especially after eating. Now, these high glycemic index foods, they take that rank, they take that scale of 70 and above. Now, these are rapidly digested and absorbed, causing sharp and rapid spike in blood sugar and also insulin levels. Example of such kind of foods are white bread. We also have white rice, most of your breakfast cereals. We have potatoes, watermelon, sugar and beverages. Those ones really, they're rapidly digested and also they cause sharp and a rapid spike in blood sugar immediately you eat them. Now we also have the medium GI foods, which will scale from 56 to 69, and these are more moderate. They cause a more moderate rise in blood sugar. Examples of such would be whole wheat bread. We also have brown rice. We have oats. We have raisins. Then lastly, we have low GI foods, which will scale from 55 and below. Now, these low GI foods are digested and absorbed more slowly, leading to a gradual and slower rise in blood sugar and insulin levels. Examples are most fruits and non-starchy vegetables. We have legumes like beans and lentils. We have nuts. We have whole grains. We have barley and quinoa. You can call it like that. Then we are going to look at something we call a glycemic index, as you see on your screen. Now, I want you to think of your body like a car engine. And these high GI foods are like rocket fuel. They burn very quickly, giving a sudden burst of energy, but leading to a crash later. Now, low GI foods are like low burning logs on a fire. They provide sustained and steady energy over a longer period. There are important limitations about this, and we are saying that GI is not the whole story. While useful, the glycemic index has significant limitations and should not be considered as the only tool you use to choose foods. It doesn't consider portion or size. So the GI value is based on eating 50 grams of carbohydrates from a food, not 50 grams of the food itself. Now we are going to give an example of a watermelon which has a high GI of around 72. However, a typical serving of a watermelon contains very few actual carbohydrates because watermelon is mostly water. So its overall impact on your blood sugar is low. So this leads to the concept of what we call glycemic load. Now, what is this glycemic load? We are saying that glycemic load is a more useful measure. And the glycemic load combines the quality GI, the quality glycemic index of the carbohydrate, with the quantity or portion in a typical serving. So it is often considered a more accurate picture of a food's real-world impact. Now, as you'll be seeing on your screen, we have a formula for that glycemic load, and we find it by calculating it this way. A glycemic load will be equal to glycemic index. You multiply that one by the grams of carbohydrate per serving. Take, for instance, our watermelon. Our watermelon has had a glycemic index of 72, which is considered high. Now, that 72, but serving watermelon has only 5 grams of carbohydrate. So, to get that glycemic load of that food, you take 72 GIs of 72, you multiply that one by 5. That is the carbohydrate per serving. Then you divide that one by 100. You get a 3.6, and that is considered as low. And if you take a potato's GI is 85. A serving has 30 grams of carbohydrate. Its GL, or glycemic load, will be 5 multiplied by 30, and then you divide by 100. It is going to give you that figure, and that is considered as high. Now we have things like fats, fiber, and proteins. They are very important on our diet, but they also slow down digestion. So a food's GI can change based on what you eat it with. Example, you can take a slice of white bread, which has a higher GI. This one will raise your blood sugar much faster than that same slice of bread eaten maybe as part of a sandwich with maybe turkey, cheese, or maybe an avocado. So the fat and protein lower the overall glycemic response of the meal. We are also seeing ripeness and processing. Now, when you see or when you eat a ripe banana has a higher GI than a less ripe one, and also fruit juice. A fruit juice has a higher GI than whole fruit because the fiber from the fruit has already been removed. Now, not all GI foods are healthy. Foods like chocolate or pizza, we love pizza so much, can have a medium GI due to their high fat content, which slows digestion. But they may also be high in unhealthy fat, calories, and also sodium. If we use a teaspoon of sugar as our baseline, we can see a fascinating story about how different foods affect our blood sugar. Like we have processed staples, we have white rice, as you're seeing on your screen. We have potatoes, we have spaghetti, and if you look at those, they send blood glucose levels soaring. However, when you turn to whole foods like an apple or a sweet corn or whole grain, the impact is far more gentle, as you are seeing on your screen. The most stable response comes from the aisles of the grocery store. The grocery store, or fibrous vegetables like broccoli and protein sources like eggs, almost show no change, as you can see, making them excellent choices for metabolic stability, as you're seeing on your screen. If you see sweet things like frozen peas, you're seeing that impact that they have on sugar levels. Now, there's also, I want you to study the next chart, Madam Reni, next slide. This is a chart that demonstrates the comparison of glycemic load of processed foods and the natural whole foods. It shows that carbohydrate can alone does not necessarily lead to higher insulin levels. Refining and processing plays a leading role in enhancing the insulin effect. Now, removing the insulin fiber, fat, and proteins in foods leaves pure concentrated carbohydrate, a form that is not naturally found. Further grinding of this carbohydrate into a fine powder such as flour increases the speed of digestion, which results in high glucose spikes. At the same time, we tend to eat more refined carbohydrates because the satiating effect of the protein, fiber, and the fat have also been lost. In general, best foods with low glycemic load for diabetics will include green leafy vegetables, the ones that they normally don't want to eat most of the time. They must eat green leafy vegetables and cruciferous vegetables. And we are seeing that cruciferous vegetables contain a broad range of valuable metabolites, which are effective in prevention of cancer. We are also saying that they need to eat a lot of beans and lentils, fruits such as apples, peaches, plums, oranges, apricots, grapefruits, and berries. Now, berries, we have blueberries, raspberries, and also blackberries. Don't forget about nuts and also the seeds from fruits or seeds from vegetables. We also have whole grains of bread, pasta, and cereals made with whole grains. We have milk alternatives, and also the dairy products. We also have cold water fish rich in omega-3 fatty acids. We are also saying that epidemiological research provides a strong evidence for dietary fiber and fiber-rich foods as having cancer preventive qualities. For instance, if you eat 500 to 800 grams of fresh fruits and vegetables, including 3 to 5 varieties of vegetables and 2 to 4 varieties of fruits, that one is going to help you a lot. We're also saying that you should eat 300 to 500 grams of whole grains and also beans. Now, if you eat this kind of food, as we are saying, that epidemiological research proves strongly that these kind of foods act as cancer, they have cancer preventive qualities. We are also saying that vegetables and fruits are high in important micronutrients like beta-carotene, vitamin A, vitamin E, vitamin C, and selenium, which we get from these vegetables and fruits, are known for their antioxidative properties. Vitamins like vitamin D, calcium, and folic acid also play important roles in safeguarding health and avoiding cancer. Now, through a multitude of processes such as antioxidation and proliferation and DNA repair, these essential nutrients are vital for supporting the body's defense mechanisms against cancer and other health issues. Research suggests that omega-3 fatty acid supplementation could result in a significant reduction in human skin cancer incidence. It is probable that omega-3 fatty acid supplementation could have beneficial effects on a range of other inflammatory diseases. Research also proves that anthocyanins and phenolic acid and other phytonutrients found in berries possess antioxidant and anti-inflammatory properties as well as anti-cancer potentials. Now, evidence suggests that blueberries and their bioactive constituents show promise in the prevention of several cancers of the gastrointestinal tract. Blueberries also show promise as a chemopreventive agent for mammary tumors. Researchers from University of Porto and also New Jersey of Lisbon, Portugal, have discovered that in both cell lines of breast cancer, blueberry extract significantly reduced cell proliferation. We have Dr. Yu Jiang-Fang, who works in the School of Medicine at the University of Missouri in Columbia. And his colleague recently reported their results in pathology and oncology research that anthocyanin and resveratrol in blueberries will slow progress of cancer by blocking the development of blood vessels feeding malignant cells, as Madam Rennie was showing you. And a team of researchers also from Taipei Medical University and Academia Sinica in Taiwan found that antioxidant properties found in grapes, the pterostigmine found in grapes and blueberries can inhibit cancer cell invasion, a phenomenon linked to radiation exposure. So those are clear evidences, and also from our researchers there. We are going to look at insulin resistance, and equally important diet is exercise. So when it comes to improving your metabolism, there's one powerful tool that almost everyone can use, and that is exercise. Most of us are so lazy on this issue of exercise. So not only does physical activity keep your body strong and flexible, but it also plays a crucial role in managing insulin resistance. Insulin resistance occurs when your cells become less responsive to the insulin your body produces. So this insulin is a hormone that helps your cells take glucose from your body, which they use for energy. So when your cells don't respond to insulin as effectively, your blood sugar levels rise, and your body produces even more insulin to compensate. Over time, insulin resistance can lead to higher levels of insulin in the bloodstream, a condition known as hyperinsulinemia. It is often associated with type diabetes, as we had seen earlier, obesity, metabolic syndrome, and certain types of cancer. Now, how does exercise really help improve insulin sensitivity? Remember, this is one of the therapies, this is one of the things we're doing for cancer prevention and management. So how does exercise help improve insulin sensitivity? Now, exercise-induced insulin sensitivity is one of the most significant benefits of physical activity. So whether you exercise, when you exercise, your muscles become more sensitive to insulin, which means they can take in more glucose from the bloodstream. This lowers your blood sugar levels and helps prevent spikes in insulin. Essentially, regular exercise can also help your body use insulin more effectively, even if you have insulin resistance. There are a few reasons why exercise improves insulin sensitivity. One being for muscle contraction, as we are seeing there. When you exercise, especially during activities like weightlifting or aerobic exercises, your muscles contract. So this muscle contraction helps move glucose into your cells, even without the need for insulin. Over time, this helps your body become more efficient at using insulin. The second reason is that regular exercise, regular physical activity increases the number of insulin receptors in your cells, which makes it easier for glucose to enter. Now, this means your body doesn't need as much insulin to replace blood sugar levels. Exercises can also help you lose body fat, which is one of the major contributors to insulin resistance. So we are saying fat cells, especially those around your abdomen, lower abdomen upper, release hormones that can interfere with insulin action by reducing, I'm saying that exercise can help you lose body fat, which is one of the major contributions to insulin resistance. So for cells, especially those around your the abdomen, release hormones that can interfere with insulin action by reducing your body fat. Exercise can improve insulin sensitivity and help regulate blood sugar levels. Physical activity also improves circulation, which enhances the delivery of oxygen and nutrients to your muscles. This helps them function more efficiently, which in turn improves insulin sensitivity. During exercise, your body needs more energy. And as mentioned, glucose is key fuel source. However, your body doesn't need as much insulin during exercise because your muscles become more effective in glucose. Now, without the help of insulin. In fact, studies show that insulin levels decrease. They decrease during physical activity as the demand for insulin is lower when your muscles are using glucose directly from your bloodstream. Now, this decrease in insulin level is a protective mechanism allowing your muscles to access and use glucose effectively in your system. Now, as your muscles become more sensitive to insulin, they don't require as much of the hormone to get the job done. This is why regular exercise reduces insulin resistance and improves your overall metabolic health. We want to see best exercises for insulin resistance. As you're seeing on your screen, we have aerobic exercises, we have strength training, we have high intensity training, and also stretching and flexibility. So these aerobic exercises or aerobic activities like walking. Now, most of us don't know that walking is also an aerobic or running. Now we are saying that aerobic exercises like walking, running, cycling, swimming, and also dancing are excellent choices for improving insulin sensitivity. These exercises increases your heart rate and make your muscles work harder. So these exercises increases your heart rate and makes your muscles work harder, which helps them become more sensitive to insulin. Now, when you're doing these aerobic exercises, you're supposed to take at least 30 minutes of that moderate aerobic exercise at least 5 days a week, which can help you improve insulin resistance. Yeah, that is what we are saying. Now, we are also seeing the second exercise being strength training. Now, this strength training or resistance exercise is another effective way to boost insulin sensitivity. Now, we have those people who do weightlifting, those ones will help you a lot, body weight exercises and resistance. Band workouts can help build muscle mass, which in turn improve glucose uptake. So the more muscle mass you have, the more glucose your body can store and use for energy, reducing the likelihood of insulin resistance. We also have HIIT. You can see HIIT. The third one, high intensity interval training. So this one involves short bursts of intense activity followed by brief periods of rest. So this type of exercise has been shown to significantly improve insulin sensitivity and reduce fat mass, both of which help combat insulin resistance. Now, it can be done with a variety of exercises, including running, cycling, or even body weight exercise. Then stretches are also good trainings. While stretching and flexibility exercises might not directly impact insulin resistance in the same way as aerobic or strength training, they can still be beneficial for overall health and wellness. So stretching can improve blood flow, reduce stress, and also enhance mobility, all of which contribute to better metabolic health. Now, some people don't know that we're not just supposed to exercise just like that. There's a duration of exercise, and the amount of exercise is needed to improve insulin sensitivity varies depending on the individual. However, most experts recommend at least 150 minutes of moderate intensity aerobic exercises per week, along with 2 or more days of strength training if you're just starting out. Now, it is also important that when you're starting out, you begin slowly. You don't do vigorous exercises. You just start. You begin slowly and gradually increase the intensity and duration of your workouts. Okay. Now, you're seeing exercises plays a crucial role in managing insulin resistance and improving overall metabolic health. Physical activities help your body become more efficient at using insulin and regulating blood sugar levels. The key is to find an exercise routine that works out for you and stick with it. Aerobic exercises, strength training, and high intensity interval training are all excellent choices for boosting insulin sensitivity. By prioritizing regular exercises, you can reduce your risk of developing insulin resistance, improve your metabolic health, and feel better in the process. Now, lastly, we are going to see these Greenwald products, and we're saying that are going to help us in the prevention of cancer. And we're saying that in Greenwald Health Product Series, certain dietary supplements, herbal remedies, herbal teas, and blueberry products are among the market approved products for cancer prevention and management. Now, Greenwald products are believed worldwide, in fact, globally, to be able to support the prevention and management of the following types of cancer. One of them being prostate cancer, breast cancer, lung cancer, colorectal cancer, and also kidney, urinary tract, and bladder cancer. Now, what is prostate cancer? We have said this is one of the cancers that is managed very well by use of Greenwald products. Now, prostate cancer is a common cancer that develops in the prostate. This prostate is a small walnut-shaped gland located below the bladder and surrounds the urethra in men that produce seminal fluid. It is one of the most common cancers in men. While often slowly growing, it can be aggressive sometimes, and the risk increases significantly with age, with the majority of cases diagnosed in men over 65 years. They're also saying that family history and ethnicity are key factors contributing to this disease. Higher incidence have also been found to be higher in Black men. For prevention and alleviating prostate cancer, we recommend those kind of products as you see on your screen. Those people who have prostate cancer or who have been diagnosed with prostate cancer, we recommend Prostate capsule for you, kidney tonifying capsule for men. We have zinc tablet and also lycopene. We are going to move to the next type of cancer. I'm going to talk about breast cancer. I'm not going to look at those ingredients in Prostate one by one. We are going to see what breast cancer is. Now, breast cancer is very common in women, and breast cancer is a disease in which cells in the breast grow out of control. Now, these cells usually form a tumor that can often be seen or on an X-ray or when you go and do a mammogram or felt as a lump. It is most commonly diagnosed it is the most commonly diagnosed cancer in women worldwide. For breast cancer, we can recommend breast care tea, as you see on your screen. We have soy power capsule, we have Hepature, and also pine pollen tea. Now, moving on to the next type, we have lung and bronchus cancer. Lung and bronchus cancer is a type of cancer that begins in the lung, which are part of the respiratory system and responsible for oxygen exchange. It is one of the most common and serious types of cancer worldwide. Lung and bronchus cancer occurs when abnormal cells in the lungs grow uncontrollably, forming tumors that interfere with the normal lung function. If not treated, these cancer cells can spread to other parts of the body. And it is this characteristic of cancer spreading, it is the characteristic of metastasizing or metastasize or metastasis is what makes cancer a more deadly and a killer disease. Now, for lung and bronchial cancer, we may recommend the products you're seeing on your screen. We have Clear Lung Tea, we have Cordyceps Plus capsule, we also have Ganoderma Plus capsule. And going on to the next one, we are going to see colorectal cancer. Colorectal cancer is a disease where abnormal cells form a malignant tumor in the large intestine or your colon, which is the final part of the digestive tract. Now, most colon cancers begin as an uncancerous growth or called polyps. Now, over time, some polyps can become cancerous. This slow progression allows for early detection and prevention through screening. And in all types of cancers, most of the times when they start with no symptoms. So if you are that type of a person, or you are somebody who you only go to the hospital when you're sick, this may be very dangerous for you. Now we need to start embracing this habit of just going for screenings, early checkup, so that you can always detect something when it is coming before it is even worse. Now, for colorectal cancer, we recommend products on your screen. As you can see, we have Candinjin, Inclisium tea, and also Chitosan capsule. You're not going to look at those products in details. And lastly, we are saying okay. Now, we have kidney, urinary tract, and bladder cancer. Now, these cancers are grouped together as urologic cancers because they affect the organ of the urinary system, which is responsible for filtering waste from the body and expelling it from the body. For kidney, urinary tract, and bladder cancer, we recommend those products you are seeing on your screen. We have Cordyceps capsule, we have Ganoderma Plus capsule, and we have blueberry juice, the high VC juice. Now, we have explained in details of each product anti-cancer properties. I just want to emphasize how blueberry juice help with the urologic cancer. The benefits stem from berries' rich concentration of phytochemicals, including anthocyanins, which give them their color. Now, we also have lactic acid and vitamin C. Now, the benefits stem from berries' rich concentration of phytochemicals, including including anthocyanins. Now, these anthocyanins, as you see, the anthocyanins are what gives the blueberry its marvelous color. Then we also have allergic acid and vitamin C. So it has anti-inflammatory effects, and we have been seeing how we need to take these anti-inflammatory products, and blueberry is one of such. Now, chronic inflammation is a known contributor to cancer development, including including anthocyanins, which give them their color. Now, in the urinary system, for example, chronic inflammation of the bladder, what we normally know or cystitis or prostate, can create an environment that provides that promotes cellular damage. The antioxidants in berries, particularly anthocyanins, help neutralize these free radicals and reduce systemic inflammation. Now, by lowering inflammation, berries may help protect the cells lining the urinary tract from damage that can lead to cancer. Now, this blueberry juice is also an antioxidant protection and DNA defense. Now, the urinary tract is commonly exposed to potential carcinogens that are filtered from the blood and concentrated in the urine. So the can cause oxidative stress and damage the DNA of cells in the blood, kidneys, and also prostate. Now, the high antioxidant content in berries acts as a defense system. Now, this helps protect cellular DNA from oxidative damage and can also support body's own DNA repair mechanism. Now, the allergic acid found in the raspberries and strawberries has been shown in lab studies to help neutralize specific carcinogens and inhibit their ability to cause mutations. And I think that is why I want to stop my sharing. Back to you, Madam Rain. Please, Kiki.
Thank you. Thank you, Madam Phoebe. Thank you so much for this presentation. So I hope that, a distributor may understand what products you can use for prevention and management of cancer. And above all, cancer is closely related to the insulin resistance or high levels of insulin and obesity. So what food you eat actually determines, how you get your soil ready for the seed of cancer to grow. So try to avoid high GI food. Try to cut the consumption of the high glycemic load food. Try to eat the whole food like the beans, vegetables, fruit, and whole grains. So this is what we are going to do. And by the way, exercise is one of the most important factors to prevent cancer and many other diseases. Believe me, exercise can also help you to generate a lot of neurotransmitters that make you stay calm and happy. So now I'm going to answer the questions in the chat box. Do you mean balsam pear tea or glucose can be one of the products used for cancer? Yes. Uh, the point is, if you find that you are in the, among those people who have insulin resistance, then you can use, one of the products. Let's see, not the glucoblock. The Boston pear tea, definitely. Believe me, even for people without diabetes, we drink the Boston pear tea. So if you are the one who most of the time feel tired, you're above 40 years, and you have a sedentary lifestyle, then very possibly you have the insulin resistance. You can use the Boston pear tea, no problem at all. And let's go to the next Can exercise increase growth of fibroid? Definitely no. Exercise doesn't have any side effect if you know what type of exercise you can do, or if you know how to control the frequencies and the dose of the exercise. So exercise doesn't have any side effects. It doesn't increase the growth of fibroids. Let's go to the next. Uh, okay, let's go to the next. Uh, People need sound. Okay, let's see. Let's go to the next. Can we use Chitosan for the breast cancer? Definitely. You know, what's the combination I gave, here to you is the basic one. Definitely, you can extend the combination of products by including other ones, especially the Chitosan. So let us ask you one question. If the breast cancer is closely related to obesity, overweight, insulin resistance, Chitosan is definitely one of the products can help because it is a fat magnet and it also help us with the insulin resistance. So definitely you can add the Chitosan to prevent the cancer. So kindly send us the PDF. We'll definitely send it to you. So after this, we are going to send both of this slideshow and the notes to Mr. Fred. And I'm going to send them to Mr. Budiman. So he's going to share this in the WhatsApp group. So do we have any more questions? If we don't any more questions today, I'm going to quickly recap today's presentation. Yes, cancer is a growth. That is very true. But by only know this is not enough. And second, cancer is caused by mutations, the gene mutations. Also very true. But what if those people who don't have cancer, they also have a lot of mutated genes. So what makes the difference? So number one, the mutated genes are the seed of the cancers. But let's look at the other factors, the soil. So if the soil is bad, if the soil can facilitate the growth of the cancer, so it means that with two heat, the heat number one is the seed, and the second heat is the soil. So what if we cannot do anything about the mutation of the seed? Then let's focus on the soil. Well, we can try to avoid, being exposed to the carcinogens like the asbestos, smoking, radiation, UV, very strong UV rays. Yes, we can do that. But we can also do something on the soil to stop the seed of the cancer growing in the bad soil by exercising, by eating the right food, the low GI food and low glycemic load food, and also by using the Greenwood products. So I think, Madam Phoebe has introduced what products you are supposed to use to prevent and manage cancer. So now I hope you find this kind of presentation helpful to your health and also your business. Now we can unmute each one and every one of us and see thank you and good night. Yes, Miss Eric Towell. Yes, to be associated with a company that's keen on consistently building the skills. Yes, we can see we are actually very proud to see so many new trainers growing in Kenya. We thank you so much for, I just talked to Mr. William Su this afternoon. We had a meeting at the office and we talked about the training of the year 2026, and we hope that next year we are going to have more of the trainings, and also we're going to develop more trainers like Madam Phoebe. Believe me, we introduced the 4 excellent trainers for this year from Kenya branch, and gradually one by one are going to be involved in this Zoom meeting. So thank you very much, Madam Phoebe, once again. Thank you thank you for your presentation, and
Thank
please
you.
you can unmute yourself and see Asante Sana. Say thank you to Madam Phoebe, and we're going to end for today's section. We're going to see you next Friday. Thank you.
Thank you, Madam Rainey. Good night.
Thank you. Good night.
Night.
Thank you. Good night.
Good night, Madam Rainey. Good night, Madam Phoebe. Good night,
Good night.